Hi all, this is Rajarshi Tarafdar. Today I am going to talk about the topic optimizing LLM performance. We'll strategize different optimization strategies for this LLM performance. So coming to the next slide. So our agenda for this talk is we'll first go through the introduction to the LLM optimization. Then there comes the challenge. What challenges we are facing in terms of the like a performance modularity. We will look into those use cases for the challenges. And there are different scaling strategies we'll be going through in details and various use cases. In this talk, we'll be focusing more about the hardware scaling techniques, then model distillation approach, and distributed systems for LLMs. And we'll be just doing, various case studies for the different domains. Like we have taken examples of few industry case studies for these LLM scalings, and we'll go through different metrics for the performance evaluation. So in terms of the efficiency, responsiveness, performance issues, we'll go through those particular metrics for LLM optimizations. And in the end, we'll go through the pros and cons of the scaling methods, what will be more advantage over the other, and in terms of the metrics. And lastly, we'll talk about the future directions, like what the LLM optimizations brings to us, and what is our future in terms of the LLM optimization. So this is a kind of like a brief overview of the agenda what we'll be speaking today. Just if you don't know about the LLM, from the very basic like a perspective, I just like to go through a little bit basic details like what are the LLMs. LLMs are the large language models, which are basically the artificial intelligence models, and it's trained on the large data set. Currently in our like industry, consider the finance domain or healthcare domain, we have to work on multiple, multi huge set of the data. LLMs definitely take into consideration that, and we are using different kind of LLMs nowadays. Like for example, ChatGPT is there, Llama is there, then Gemini, etc. It's different providers. Those basically form, like kind of text generation, email generation. So those kind of applications of the LLMs are there, and it's like kind of broad user perspective. Like it helps in multi scenarios like email generation, text generation, then question and answering sessions, like, and then language translations and sentiment analysis. So it's a kind of broader perspective for the from the applications of the LLMs. Now, coming to the challenges in the optimization. There are like a different challenges which we come across the LLM optimizations field. It's kind of computational cost. The industries needs to be very careful when they are deploying some LLM in terms of the cost, and also the data quality. And in terms of the different industries, let's consider the finance, and sometimes a global bank. If you consider, the data needs to be very in a secure environment, like it needs to be in a very controlled environment. So we need to very careful about the quality of the data. It needs to be very compliant, otherwise security issues may arise. And there comes the model bias, also one of the challenges in the optimization. And we discussed about multiple techniques for this optimization. So, such as like fine tuning and then parameter efficient methods, regularization, pruning. So, there are other techniques also. We'll just discuss in details in the next slides. So here we'll go through a little bit like the LLM optimization introduction. So as I mentioned already, like large language models are like powerful AI systems that are trained on the vast data sets, and it will generate a human-like text response, and in the form of the human readable response. So the LLMs are needs to be optimized in terms of the performance, latency, and cost, so that the applications can be integrated easily with the LLMs. And we can take examples of multiple sectors where the LLMs can be used, such as healthcare, finance, customer service. So it's kind of like multi-industry domain it can be applied to. And the optimization techniques includes fine tuning, pruning, and distillation. So all basically try to improve the model efficiency of the LLMs. And now LLM needs to be very optimized in terms of the like meeting the user demands, and it's can be so that it can be used mostly in the broader industry use. So coming to the like challenges in the LLM deployment. So currently, if you see from like different use cases like a financial perspective or like healthcare perspective, we are like there are large amount of data, and for that it signifies the computational resource. So it needs to be like very reduce the like resources. That is one of the primary challenge in case of the LLM deployment. In case of the costing, it needs to be reduced. It has a high operational cost for training and the interference purposes. And apart from that, latency issues are also there. Like the real-time applications suffer from latency. When the models are large, the latency gets just reduce the latency for the applications. So basically, the user experience is impacted. So in order to, we need to optimize those pain points. And there are also scalability issues sometimes due to the complex in the resources allocation and management. Scalability also causes an issue in the LLM deployment, so we need to take care of that. In this slide, we'll just go through the different strategies for this scaling up. And we have just in short mentioned the four like strategies here. First is the hardware scaling, where we are dealing with the GPUs and the TPUs, which enhances the computational power, and it helps in faster processing and largest dataset handling. So there are various techniques also in the hardware scaling. We'll discuss more in details in the next slides. And then there comes the model distillation. So it basically just distributes the complex models into smaller chunks, therefore making the efficient versions and also maintaining the precision and accuracy. And then the distributed systems, it is used for parallel processing. There are various strategies also into the distributed system. We'll discuss in more details. It is basically in high level just help to reduce the latency and improve the scalability. And optimization techniques. So we can use different algorithms for the efficiency increase in the strategies for this. The resources can be used better, and the response time is reduced. We'll discuss more about the hardware scaling in the next slide. So this is, if you see, basically we have to use multiple processors for the hardware scaling, and there can be scaling can be done in like a horizontal scaling or the like a vertical scaling. So there are like a hardware upgrades also there, and like the we can just improve the training performance by upgrading the CPU and the GPU or the TPU hardware. So and we can use the specialized hardware also, like which are particularly suitable for the machine learning task. And then comes the model parallelism. So we are basically dividing a model across multiple devices for parallel processing, and so it will definitely increase the efficiency of the model. And also there is another strategy for that, like hardware scaling. We are splitting up the data across the different devices, which is come across the parallel computations, and this gains the response time a lot. So here there are like a two major scalability techniques for the hardware, and one is the GPU utilization. So GPU utilization like accelerate matrix operations, for the training and the interference, and parallel processing capabilities also improve the GPU utilization a lot. um, we are like come across different scenarios where like NVIDIA A100 and V100 GPUs are popular choices. It increases the GPU. I mean, it helps in the scaling techniques like for the hardware. And the TPU are specifically designed for the machine learning task. It will increase the throughput, and if your LLM is dealing with a large amount of data, they basically optimized for the TPU reference, and for the tensor processing in particular, these are optimized for. And Google's TPU offers like its energy efficiency and the speed also in terms of the advantage for this TPU. And these are the primary two things, like GPU and the TPU for the hardware scaling. I have just mentioned few use cases on the hardware scaling techniques. So initial GPU adoption for the LLM training, it is done in 2015. It's the early adoptions, and so they basically leverage the parallel processing capabilities where they are dealing with the large data sets. And we just go through the evolution how these improvements happen year by year. So in 2017, the TPU introduction happened, like where it is specifically designed for machine learning workloads. It is just launched by the Google, I mean 2017, for the tensor processing units, TPUs. And 2019, NVIDIA launched the A100 GPU, which is a significant milestone in terms of the speed and the scalability. And 2020 is like it's hybrid scaling approaches many companies have been going through, like they have integrating both the GPUs and the TPUs. So like they are useful for optimizing the resources in terms of the performance. And then the evolution comes in the cloud based scaling, where the different cloud platforms provided elastic scaling options, allowing the organizations to dynamically allocate the resource to make the resource allocation more efficient. And the edge computing adoption, it enables the LLMs to operate to the data source. I mean, the integration is far better in terms of the edge computing, and it drastically reduces the latency. And then there comes the AI specific hardware, like which are particularly AI specific chips, which are tailored for the particularly the machine learning task, and reduces the energy consumptions in the data center. And coming to 2025, we have seen a rise in the the research in the quantum computation. So quantum computing for the LLMs also just provides a lot of promises in the processing power and the efficiency. So basically, the model distillation approach, we have tried to give some like info for the model distillation. Basically, it's a teacher-student kind of model where it is basically the transferring the knowledge between them. And how the process works is that, like, we are training the student model on the output of the teacher, and based on that, the patterns and the features are capturing, and we are creating a more performance based model, so it makes the model more efficient. So this is in high level the model distillation approach. So it's basically divides into just training smaller models to replicate the behavior of the larger models. So you can just process starts with the larger model. I mean the teacher model, which is generally like soft targets, and there can be various likely responses. Uh, this is to just train the model, I mean student model, to learn from the teacher, and to match its complexity. So the techniques, I mean, can reduce the number of the parameters and to process, and also increasing the the memory. I mean, reducing the memory consumption, and also just response time is much more faster. And the distillation can can it's a very efficient model. I mean, compared to the uh, larger model, it performs I mean good computational mechanism, so it's obviously like good performance one. It's basically different types of the distillation exist. So including the feature distillation and logic distillation. So both are focusing on the different aspects of the outputs for the larger model. And here we also go through the like a use case on the model approach, model distillation approach. And in 2017, Geoffrey Hinton and his team introduced the concept of the knowledge distillation. It lays the foundation of the model compression techniques in the deep learning. And 2018, I have just taken just research to a use case where a major tech company successfully distilled LLM, reducing its size by almost 50%, while maintaining almost 95% of its accuracy. And 2019, there is like it has been applied to multiple real-time applications, therefore reducing the latency and improvement of the user experience in the AI-driven customer solutions. And 2020, there is a significant improvement in the healthcare. I mean, of these adoptions of this model in this healthcare, and which improves, the lesser response time, and the accuracy is also improved. And 2021, there are new techniques introduced, and allowing the student models not to just learn from the outputs, but also from the intermediate features. Therefore, like helps in increasing the performance. And in 2022, there is distillation on the edge. So there are new techniques, which are added to enable the deployment of the efficient models, optimizing resource usage. So it's evolved again in 2023, where we the federated learning has been introduced with the concept of this model distillation, and we have performed the on the top of the decentralized data, and it helps in the maintaining the compliance purpose, for private privacy and the security of any sensitive applications which might have any constraints. Uh, then regulation and the compliance. So it is just for the different regulatory bodies. It helps to maintain the AI models compliance and the regulatory measures. So we are currently dealing with a large amount of data, and it's essential to maintain the value of those data in terms of the privacy. So regulation and compliance, bodies just recognize this model distillation. It is for maintaining a standard in terms of the security. And then coming to the distributed systems, so in terms of the distributed systems for the LLMs, we are going through different parallelism, like data one, and then model and the pipeline one. So this is a high level diagram of the distributed systems for LLMs. And coming to the benefits, how the distributed systems are helps in the LLMs optimization. So it enables the parallel processing and the model training. There, I mean, significantly reducing the training time, and it just splits the load, across the multiple nodes, and therefore, increasing the resource utilization. And it also drastically reduces the fault tolerance, and the reliability of the model is also increased for this. And it also increases the scalability in terms of the organizations wants to expand their resources and the like a model size for the large amount of the data. So this distributed system can help a lot, and therefore these implementation strategies are also integrated with different cloud platforms, which helped in the dynamic allocation of the resources, so the load can be distributed. And the microservice, it is basically on the microservice architecture, which is uh, just adapted into smaller chips and chunks, and that can be deployed independently, therefore making it more modular. And there is also a models hardening techniques, where we can split the models into different nodes, and we have to optimize the memory and the processing capabilities that drastically improves. And we also explored the solutions of the Kubernetes in terms of the deployment and the ECS. So this Kubernetes, just help for managing the deployment, and this one drastically increases the efficiency of the model. And there are various use cases on the distributed systems for LLMs, early distributed computing, microservices adoption, uh, cloud-based systems, Kubernetes deployment, models herding, edge computing, fault tolerance, and AI specific chips. So, in the early distributed, computing, organizations began in the manage the LLM training, enabling parallel processing and reducing the computational bottlenecks. For the microservice adoption, we already mentioned it is divided into independent blocks, making into more modular. And cloud-based systems is also, helps in the elastic resources for the LLMs. And Kubernetes is also integrated into this LLMs later. And model sharding is basically the efficient allocation of resources, which comes in the later part. And the 2024 latest one is for AI specific chips, where the development of the AI specific chips enable more efficient distributed processing and resource allocation in the data centers. So if you see, there are various optimization techniques here. So one is for gradient descent, and so it's basically adjust the model parameters, and regularization is there, which is adds the penalties for the loss function to prevent overfitting, and it is just generating a learning feedback loop where it's just adjust the increase or decrease the learning rate based on the training. And another technique is the gradient clipping, which limits the size of the gradient to prevent the exploding gradients. So there are like a different optimization techniques. If you see like a model pruning, quantization, adoption, knowledge distillation, and hybrid models comes in 2020, which is the basically integration of the both. And 2021, if you see like a energy efficient architecture has come into place, like to optimize the like a power consumption during training and interface. And 2022 federated learning techniques are improved, allowing the LLMs to learn from decentralized data. So there are like a various, I have shown the evolution how it helps. Now we have taken a case study for the successful LLM scaling. So one leading tech company just they implemented a hybrid scaling strategy that combines the both the hardware upgrades and the model distillation. So it helps in increasing the performance and in terms of the processing speed and up to 40%. And it's a model distillation is also applied there, and therefore like reducing the resource requirements, and but with more precision and accuracy. And the deployment cost reduced significantly by almost 30% for this just integrating both the model distillation and the this taking this hybrid strategy. And this post implementation metrics show almost like a 50% improvement in the throughput and a significant enhancement in user satisfaction. Now coming to the various metrics for performance evaluation. So there is an interference speed almost improved by 200 microseconds, and then accuracy rate almost 95%, and resource utilization by 70% CPU, and latency by 50 milliseconds. So these metrics we have taken into account for this performance evaluation. And there are various pros and cons of the like a different scaling methods. Like the it helps in improving the processing speed with the reducing the response time, and it drastically reduces the resource requirement. And but it does with the precision and the accuracy, which is definitely needed in today's industry, with which is dealing with a large amount of the data sets. And it can just vary across different use case and requirements, so we can adjust these scenarios accordingly. And the effectiveness is one of the primary reasons we can just it can help with it. And but the issue is like sometimes the higher initial investment is required for the hardware scaling, that can be a barrier for some organizations. And the managing distributed systems can also introduce sometimes the larger amount of the complexity, which will definitely require much more training and knowledge. And the increased latency also sometimes cause the synchronization issues actually. So the trade-offs between the performance and the resource consumptions can complicate the scaling decisions. So these are some of the pros and cons of the scaling methods. And future directions, we are using the just make the architecture more scalable and with the reduced parameters, and we have to aim the just minimizing the computational load to increase make it more optimized. And we also have to make improving the training techniques, allowing the models to adapt to new tasks with the minimal data and data input. And therefore, we have to deal with a large amount of data. We have to see whether the like a privacy and compliance is maintained. So we have to just take those into account. And also federated learning is needs to be enabled more from the perspective of the decentralized data sources to maintain compliance and regularity with the data. Yeah, thank you. If you have any questions, let me know.